Hello, today we are going to dive into the world of electronics to answer a fundamental question. What is a capacitor and how does it work? By the end of this video, you will be able to 1. Describe the physical structure of a capacitor, and 2. Explain how a capacitor stores and releases electrical energy using the concept of electric fields. Think of a capacitor as a temporary battery or an energy reservoir for your electronic devices. It is one of the big three passive components in electronics, alongside resistors and inductors. To understand how it works, we first need to look at what is inside. Our first goal is to understand the physical makeup of this component. In its simplest form, a capacitor consists of two conductive plates. These are usually made of metal, like aluminum. Crucially, these plates do not touch. They are separated by an insulating material called a dielectric. The dielectric can be many things: air, paper, ceramic, or even plastic. Its job is to block the flow of direct current while allowing an electric field to exist between the plates. When we connect these plates to a circuit, they provide a place for electrical charge to accumulate. Now we have seen the structure: two conductors separated by an insulator. Next, we will see what happens when we turn the power on. Now, let's look at the charging process. This is how the capacitor actually stores energy. Imagine we connect our capacitor to a battery. The battery acts like a pump for electrons. When we close the switch, the battery pulls electrons from one plate and pushes them onto the other. As electrons pile up on the left plate, it becomes negatively charged, because like charges repel, these electrons push away the electrons on the opposite plate, leaving it with a positive charge. Even though no charge can cross the gap because of the dielectric, an electric field forms between the plates. This field is where the energy is actually stored. The flow of electrons continues until the electrical pressure, or voltage, across the capacitor is exactly equal to the voltage of the battery. At this point, the capacitor is fully charged. Take a moment to think about this. The energy isn't stored as a chemical reaction like in a battery. It's stored in the physical tension of the electric field. Once the capacitor is charged, it acts like a loaded spring. It is holding onto that energy until the circuit gives it a path to escape. Our next goal is to understand the discharging process. If we remove the battery and replace it with a component like a light-emitting diode, or LED, the stored electrons finally have a way to get back to the positive side. The electrons rush through the circuit, lighting up the LED as they move. This is called discharging. Notice that as the charges neutralize each other, the electric field weakens and the voltage drops. Unlike a battery that provides a steady flow for a long time, a capacitor usually releases its energy very quickly. This ability to charge and discharge rapidly makes capacitors perfect for filtering signals, smoothing out power fluctuations, or providing a sudden burst of energy, like in a camera flash. We have now met our objective of explaining how energy is stored in the field and released through electron flow. To wrap things up, let's summarize the key points we've covered about these essential components. We started by looking at the physical build of a capacitor. Remember, it is simply two conducting plates separated by an insulating dielectric. This gap is what prevents the flow of direct current while allowing energy to build up. We then explored how it works. By using a battery to move electrons from one plate to another, we create an electric field. This field is the container for the stored electrical energy. Finally, we saw that a capacitor can discharge that energy almost instantly when the circuit allows it. A common real-world example is a camera flash. A small battery slowly charges up a large capacitor, which then dumps all its energy into the flash bulb in a fraction of a second to create that brilliant burst of light. You should now be able to describe the structure of a capacitor and explain how it stores and releases energy through electric fields. Thanks for watching, and keep exploring the fascinating world of electronics.